streaming. Okay, so streaming is on, and we are ready to get started with today's lecture. All right, so let's go to the correct class. Today is a Tuesday, Thursday. And what we'll do is we are going to take a look at exam 1 from last semester. This is our practice test. Next Tuesday is the actual test. So 1 week from today is the actual test. Same classroom, okay, same place, same time. We're going to use the lecture time for the test and not the lab time. Okay, so there won't be any extension into the lab time. We'll only be using the lecture time for the exam. You can find it inside the share folder. I'm hoping that some of you have looked at it already because I think I told you guys about the share folder at least last time. And when you look into the share folder, you will find X1, which is exam 1 or old X1. And that's where you'll find some of the previous exams for this class. I'll focus on the one that I just gave last semester as exam 1, because the more recent, the more likely I would use the same kind of question. But since I let you guys keep track and share and print all the previous exams, that kind of implies that I do not recycle or reuse any questions from the past, which is really fun for me because I have to keep thinking about new ways of asking questions. But it's a personal challenge. I look at it as a positive thing. Your opinion may differ. All right, so what I'll do is I'm going to download it. It's a PDF. You can just go ahead and download one version for yourself as well. And I'll put it into my download folder. One good thing about Zerno is it can open PDFs. So I can use Zerno to mark up an existing PDF. So I'm going to pull Zerno over here. There we go. And open in my, okay, go to downloads. And we're looking at the file that we just downloaded. This is the one. Okay, so let's zoom to page width. There we go. All right. So I'll start from the very beginning. Make sure that you write down your name and your student number first, okay? Because I don't want people to scramble to write down their name or forgetting to do that at the end of the exam. So do that first. I do want you to write down your last name first. So last name is also known as surname or family name, and then your given name is on the second line. Your student ID is also important, just in case I cannot read some of the handwritings. Okay, every semester for every exam, there are at least, I would say 20%, of the names that I cannot read entirely, but I can read enough to differentiate and find out exactly who that person is in class. So try to write your name, in a clear way so that I can tell who it is before, without having to look into my roster and try to make a match. Obviously, the time is going to be different, okay, and the date is going to be different, okay, so that part is pretty clear. It is open material. In other words, you can bring in as much as you want material that is either printed or handwritten prior to the exam. So it can be a textbook. If somebody finds a textbook that talks about the material that we are talking about in this class, or you find a Wikipedia page on Carry Look Ahead, and you say, well, that seems to be explaining the stuff a lot better than text note, you can print it out and bring it with you, okay? Not a problem. If you look at, if you review, the video recording, and there's one particular screen where you say, hey, this is a really useful screen, or at least portion of it is, you can just, pause the video playback, use a screen shot tool, you know, cut out that part, put it onto a piece of paper, print it out. Okay, there's no, I don't have a problem with that either. You can use my own notes. Okay, so my class notes, is completely usable in an exam as well. Okay, if you so think that, okay, I think I'll just print out text note on binary addition and subtraction. Hey, print it out, bring it with you. Okay, so there's no restriction as long as it is on paper and it is printed or handwritten prior to the exam. Okay, if you guys want to work together and say, okay, we're going to work on a shared note just for the exam, that is not a problem either, as long as each one of you has a copy of that prior to the exam. So there won't be any sharing of material during the class except for blank paper and maybe stationaries. Okay, so if your pencil is running out of lead and you ask the next person for lead, that's probably okay. So is that clear what you can use? You can use a scientific calculator. Okay, so the same scientific calculator or graphing calculator you can use in calculus classes or physics classes. You can use that in this class as well. Is that okay? Are there any questions about what you can bring to help you with the exam? No electronic devices other than a calculator. Okay? And this year I'm going to make it very clear, no headphones during the test. Okay, so no headphones. I understand some people want to be able to play just some music to kind of drown out and to to be in a more peaceful place. But I have to not allow that any further. Okay. So any other questions about what electronic devices is allowed? Questions? All right. So we are going to move on. Yes.
Did you say during the lab we're going to review the test?
No, I'm going to use the lecture time to review for the exam, and then during the lab time, we will just be finishing whatever is still open. Yep. So if you're done with all the labs already, you don't really have to go to lab today. We are not having a new lab today, but we will be finishing whatever we started on last on last Thursday. Yeah, go ahead and then back to you.
But for the lab after this test,
Uh-huh.
will we be reviewing the test during
Yes.
Okay.
So the lab. Oh, okay. So you're referring to the actual exam, not for today. So yes. So next Tuesday, the lab of next Tuesday is going to be I will tell you what the answers are to that particular test. Okay. All right. So next is to talk about this is a individual assessment. This is getting back to the syllabus of unless I say otherwise, all assessment activities are individual. So that means the score of a particular submission should reflect the competency of the student with the name and ID as indicated above without any prior knowledge of the exam questions. Okay, so there will be no sharing of exam questions. If somebody could not make it to the exam, and you took the exam at the right time, do not share, any details about the question with that other person. Okay, if you're not sure, then you can assume that person did not make it to the exam and do not share any details about the exam. Okay. Answers should be independently and originally derived in the allotted time frame, observing all applicable rules and restrictions. So, I mean, I think that is pretty clear. Okay, everybody should work on his or her own exam and not somebody else's, and nobody should be, trying to get the answer from somebody else. Okay. No sharing of open book or notes material during the exam. Okay, so that means if somebody forgets to bring the material to be used in during the exam, you do not want to share yours. Okay, because I do not want any material sharing during the test. Is that okay? So everybody is responsible for his or her own material during the test. Okay, I think that's fair. Okay, given that we have 1 week to prepare for this, so you just have to remind yourself. Okay, bring all that material with me next Tuesday. So do not discuss the question with students who may not have taken the exam. We talked about that already. And I also want to remind everybody that this semester, I'm changing my policy. If I suspect anything, if there's any cheating and I have evidence about that, I will bring that evidence to the discipline officer on campus without any, like, oh, this is the first occurrence, I'll let it slide. But the second one I'm going to report. No, I'll be reporting every single one. Okay, so I just wanted to make it clear. Okay, hopefully, I don't have to do that at all. Use additional sheets of paper if necessary. Typically, every test, I would give you space to write your answers. And sometimes it is sufficient and sometimes it is not sufficient. So just to be sure, bring some extra sheets of paper with you. Okay, regular binder paper is fine. Okay, plain paper, copy paper is fine too. So just use common sense. Okay, whatever you usually write your notes on is probably okay. Write your name on each extra sheet of paper, just in case it gets dropped. Okay, or if when I put it into the bag, it gets the order. I lose track of the order. You want to write down the question and also your name on each additional sheet of paper. So this way, I cannot possibly lose that, or or I can look at the piece of paper and go like, whose answer is that? It's a perfect answer, but I cannot know which person deserves the point. Okay. So the question number and your name on each additional sheet of paper. Write legibly. Okay, if I cannot read or if I cannot understand the answer because the handwriting is too bad, I would just give it 0 points. Okay, I do not wait until people come to me and go like, Tech, that I really meant to write down blah blah blah. Okay, after the fact, I do not give points after the fact and wait for somebody to explain what that squiggly thing is. Okay, so you have to make sure that your handwriting is at least clear enough for me to read. Make your answers as complete as possible. If there's something that I look for to assign partial credit, I cannot and will not infer from what you write. Okay, so partial credit is usually awarded if the final answer is wrong, but I can collect from the steps or the derivation that person actually understands the concept. Okay, just in one of the steps of deriving the final answer, okay, there was a stupid mistake, which I make all the time. Okay, is that okay? So, but you want to give me a reason to give you partial credit. So that means, show your work. Okay, some of the questions will emphasize that you need to show your work and not to just give me the final answer. Okay. Let's see what else. If any proof of trace, in any proof of trace, write your answers as completely as possible. In this class, we're not going to prove anything, but there will be questions that involve multiple steps. Okay, so if there are multiple steps to solve a problem, if you write down how you solve the problem and those steps, then you have just increased your chances of getting partial credit. All questions have equal weight. I will keep that policy. This is really for your benefit because if all questions have equal weight, that means you can just have a quick, glance over all the questions, and you can start with the ones that you feel most comfortable with first. Okay, so do not try to answer the questions in the sequential order. You always start with the questions that seems the easiest to you. Okay, so you nail the questions that you know you can get points out of. Then you get back to the harder ones and see if you have enough time to deal with those. Is that okay? You also want to look at the total number of questions. So let's just say that we have a total number of 8 questions. Okay, we have 80 minutes and there are 8 questions. So that means on the average you have about 10 minutes per question. Does it make sense? So you want to keep track of time as well, so that if one question is taking too much time, then you move on to the next one. Okay, because you don't want to spend too much time on one particular question, because the next question may take less time. You may actually know the answer to the next question and be able to get those points. But if you're stuck on one particular question and refuse to give up, then you won't have a chance to start on additional other questions in the test. So you may be losing points when you don't have to lose those points. Some questions may cross pages. I try my best so that that does not happen. So you want to make sure that you read the entire question, and check that, there's not a second part on the second page. This exam, according to the syllabus, accounts for 20% of your final grade. So it counts for as many points as all of the homework assignments, all the labs added together. So it's important, okay? It is important. So do we have any questions about this page, which basically is just the overall description of exam 1? Yes.
It's not about this page, but I was actually wondering if, I don't know if it's possible, I haven't tried it. Can you go back to the previous labs and reopen it for practice?
Yes. So remind me to do that. If there's one particular lab that does not let you to look at it again, let me know. But to redo it, I cannot allow, because if I let people to redo it, then it will still continue to update the score. I cannot lock the score and then reopen the test.
Okay. But can we look at it?
Yes. So if you cannot look at a particular lab, let me know and I can just change the settings so that you can look at it at least. Yep. All right. Any additional questions before we get into the exam itself? No questions. All right. All right. So here's question 1 of 6. So I try my best, to make sure that you guys understand how many questions there are in total and which one you're on. Okay, because this way, people like my own son would not miss an entire page. Yes, he took some kind of a open exam or assessment test in middle school, and then he said, "Oh, that was quick. It's easy." Well, it turns out he missed 1/2 of the test because he didn't flip the page over. And he came out and instead of panicking, go like, "Oh no, my test is all ruined." He said, "It's okay. I understand all the stuff that they're asking me. Missing half of the questions is not a big deal." And that's my own son. And in that way, he is really like myself when I was his age. All right, so this is question 1 of 6. So I try my best to make sure that you guys know how many questions there are and which one you're on. Okay, so this way you can track your progress through the test a little bit more easily. Okay. In the following space, fill in the blanks for a 6-bit subtraction so that the subtraction yields the indicated T bits, okay? Borrow bits and D bits, the different bits. So I even explained, what those bits are, which really, you should know that by now, but it's okay. I'll explain some of that. Be sure to explain how you get the values. Note that the solution may not be unique. In other words, there may be multiple solutions to this particular problem. So then you read the question and you start with what is given to you. In other words, you start with the bits that are already in place and you go like, okay, given those bits that are given to me, how do I work my backwards to figure out the ones that are missing? Is that okay? That's kind of your job. Okay, this is kind of what you need to do. So now the question is, but Tech, there's no lab that you actually mentioned anything like this. Well, no, I did not. Okay, you're right. But it is about the application of what you have learned. Okay, I do not test whether people can memorize anything. I do not test whether people can replicate a process that we have used in lab or not. I test whether people can apply the knowledge they have learned to solve a problem. Okay, this is an example of that type of question. So the question now is, okay, I have never seen a problem like this before. Where do I start? You start with knowledge. You start with, what do I know about binary subtraction? That's where you start, okay? Because the question obviously has to do with binary subtraction. So you look up all the binary subtraction module, okay, or in your notes or whatever you bring with you, and you say, okay, given that we know what D is and what T is, can we go back and figure out the Q? In some cases, yes, and in some cases, maybe not. Okay, so we'll see what happens here, right? So now you have to remember or look up. Okay, you don't have to remember. You just have to know, somehow, how does D relate to T and Q? Well, does it relate to T and Q? It's related by what operator? Exclusive OR. So we know that Q exclusive OR T is D for each column, okay? So what is that telling you? Well, I need something exclusive or with 0 to give me a 1. What do you think that should be? Just 1 itself, okay? So I'm going to use my stylus here to pretend that I'm actually answering the question. I'll use blue so it's easy to tell the difference between my answer and the question itself. Okay, so is that okay? Does everybody understand how I come to this conclusion that this bit has to be a 1? There's no confusion. This one has to be a 1, okay? Over here, I know the result of exclusive OR is 1, and one of the things to the exclusive OR operator is a 1. What do you think the other bit is? 0. Okay, very good. So it's a 0 here. This one has to be a 1. This one has to be a 0. Is that okay? This is all based on the understanding of exclusive OR and also how exclusive OR is used to compute the difference from Q and T. Yes? I do not have the answer or the key to all of the questions. So so I'm going to work on the ones today, and you guys can. The additional ones, I can probably work on it and just give you the solution, but not in class. Okay. Okay. All right. So now we see what Q is, and now we need to go back and look at what X, Y should be, right? Now that's a little bit trickier, because if Q is a 1, then we have two possible cases. X can be 0, Y can be a 1, or the other way around. X can be a 1, Y can be a 0, because both will give us an exclusive OR result of 1. But there's one extra thing we can use, which is the borrow bit or the T bit of bit 1 position. There is a borrow here. If X is 1, Y is a 0, that would not be a borrow. So that means in this case, it has to be 0, 1. Okay. All right, so what about the next column? We end up with a borrow, okay? So we end up with a borrow that is stated here, because this one is because of this. So this one is because of this. It's already accounted for, okay? In addition, the result of the exclusive OR is a 0, which means it can be 1, 1 or 0, 0. Which one should we use? Hey, it's up to you to decide. Okay, because either one is going to work in this case. So you can choose 0, 0 or 1, 1. Okay, I'll just choose 0, 0. And by the way, this is one of those clues that I use to determine if the answer to one person is copied from another person, because there's supposed to be a 50-50% chance. Now, I'm not just going to point out somebody is cheating because of this, okay? Because they both choose to use zeros, okay? But it will be part of the consideration. I'll be looking at the pattern of all of the answers of all the questions, okay? All right, for the next one, what do we get? we have a borrow of 0 here, okay, and then a result of 1 here. So it has to be a 1, 0 in here in this case. Because if it were a 0, 1, x, if x is 0, y is 1, then we would have ended up with a borrow over here. Okay? And the last column has a result of 0. So once again, it can be 1, 1, or 0, 0. So just out of randomness, I say 1, 1. Could have been 0, 0 as well.
Could be, but it wouldn't make sense.
Why would it not make sense?
Because why would you have that column if it was all zeros? It would be a redundant column.
It would still be a 4-bit by 4-bit subtraction.
I guess it would be.
Yep.
I feel like it would make more sense for it to be 1. Because if it
Mm,
was 0, then it could just be a 3-bit.
When you have an integer or other things like that, they have a fixed size, a fixed
right.
bit, and that's true of all numbers on a computer.
Yep.
So
Right.
So even when you use 32-bit integer or 64-bit integers, most of the time in programs that you guys write, the values that you store in those will be like within what 100 usually, right? Do you need to use 64-bit for 100? No. So most of those other bits will be zeros. So don't let that trick you. Okay, it is possible that you end up with a bunch of zeros as more significant digits. Okay. All right, so that's one of the 6 questions. Moving on to the second one. The second one is a base conversion thing. And convert the following number into a base 10 mixed fraction step by step. Okay? So now we go like, oh, but we haven't done anything like this in the lab. You're correct about that. And that is the whole point. Okay? In other words, do not expect to have exactly the same kind of question as what you have seen in the lab or in previous tests. Okay? I try my best to ask whether you understand the concept in a different way every semester. That burden is on me. Okay. So now you have to look at this and understand what is it asking? What is the number that you're given with? 202.11. What is that little 3 saying? It's base 3. Okay, so you have a number that is in base 3, and I want you to represent the value of this number in base 10. But it's not just a base 10 number, it is in a mixed fraction format. What is a mixed fraction? A whole number followed by a fraction. Okay, so I'll give you an example of that, right? So now the question is, how do you do it? Well, you take this number and you ask, how do we interpret each digit, right? So you look at 202.11, okay? 202.11 in base 3 is 200 in base 3 plus 0 in base 3 plus 2 in base 3 plus 0.1 in base 3 plus 0.1 upon 0.1 in base 3. Is that okay? All right. So I turn this into 2 times 100 in base 3. Let's not count the 0, okay? That's kind of useless, okay? And that looks like ozone to me too. O3. Okay, plus 2 in base 3 plus 0.1 in base 3 plus 0.01 in base 3. All right. So the 2 is fine. What is 100 in base 3? What value is it representing? Well, we know that in any base, doesn't matter what base you're dealing with, if you have a 1 followed by a bunch of zeros, it is the base to the power of the number of zeros. So how many zeros do we count here? 2. And what base are we talking about? 3. So we're talking about 3 to the power of 2. So we have 2 times 3 to the power of 2 plus 2 times 3 to the power of 0, because there are no zeros, right? There are no zeros to the right-hand side. Oh, we got a point something here. What do we do about this? It's 1 times 3 to the power of what? -1. Very good. And what about this one? 1 times 3 to the power of negative 2. So this gives us 18. This gives us 2. This gives us 1/3. This gives us 1/9. So if you only get to this point, you'll get partial credit, okay? Not all the credit, because the question did ask for a mixed fraction, but you're only one step, arithmetic step, away from the final answer, so you get most of the credit. Yes?
Can we use calculators in the test?
You can use calculators. So if your calculator supports fractions, yes, you can definitely use that too. The question is not so much about can you carry out fraction calculations. It is about can you relate these digits into the portions, into which digit is specifying the quantity of which power of the base. That is what it's really asking. So now we have 20 and 4/9. So that would be the final answer. Now, what if somebody just skips all the steps and get to 20 and 4/9? I'm thinking about either a 0 or a D. Because it is the steps that I'm looking for. It is not so much the final answer. Now, if someone gets to only this point, okay, if someone can get down to the third line, I would call that a C. Okay, the person understands, how to break apart the digits, but did not relate it to fractions. Okay, if someone can get to this line, the fourth line, I would definitely call that a B. Okay, and obviously someone who can show all the steps and get to the final answer will get an A. Are we good so far? Okay, so show your steps. Show me your reasoning. Question number 3. Convert the following base 10 mixed fraction blah 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 into a base 7 number with decimal places, step by step. If you know how to answer question 2, don't you think number 3 is really just the reverse process? It really is. Okay, so what do I mean by reverse process? You look at 146 and 41/49. You say, how do I express the same value as quantities times powers of 7 in this case? That's what you're trying to do, okay? So the way you do this is you look at 146, in this case 41 divided by 49 as a mixed fraction, and you say, well, do we have any 49s in here? Or 7 to the power of 2. So how many 49s do we get? I think we got, 2? Okay. So we'll say it has 2 times 49. And because I cannot carry out, arithmetic operations very fast, so I'm going to say the rest is just do a subtraction. So that's 98. So we got a 40, is it 48? I think so. It's 48 and 41 divided by 49. That's the portion remaining. Okay, so then we rewrite this as 100 in base 7. Now, if you don't like to jump steps like that, you can always just kind of go step by step like that. Okay. All right, so we look at 49 and, we look at 48 and something. Obviously, we don't have enough for 49. We're just one short, right? So the next power of 7 that we're going to work with is 7 to the power of 1. So the question now is, how many 7s do we have in 49 and something? The answer is, 6 of them, right? Okay. So we now say that this is 6 times 7 to the power of 1, which is 42, so we have 6 and something left. Okay. All right, so I'll keep it the same way as before. So with 6 and something, how many 1s do we have? Because now we're working down to 7 to the power of 0. That's pretty clear. Right? Okay, and then we have the fractional part left. And then what do we do? Well, we looked at fractional part and we asked the same question. But this time we are asking about 7 to the power of negative 1. In other words, we are looking at how many sevenths do we have in 41 divided by 49. There are 5.
Yeah.
Yeah. So there are 5 times 7 to the power of negative 1. And what is left? 6 divided by 49. Okay. So now this becomes 2 times 7 to the power of 2, 6 times 7 to the power of 1, 6 times 7 to the power of 0, 5 times 7 to the power of negative 1, and then 6 times 7 to the power of negative 2. So we can say this is now 266.56 in base 7. It's basically the reverse of the previous question. Yes,
So is that exact?
it is exact. Yes, it is exact. Both questions are really asking about the same thing. Do you know what the number is? Do you know what value a particular number is representing? It's really asking the same thing, except in the direction is different. One is giving you a representation that we are familiar with, and the other one, see, this is what we are familiar with as with a base 10 number. Asking you, how do we represent the same quantity in base 7? The other one is asking the opposite. It starts with a representation that we are not familiar with, and then trying to convert it back to something that we are familiar with. Yes?
So this solution would get full credit.
Yes. Yep. I mean, I did skip like 2, 0, 0 plus 6, 0 plus 6, but that's kind of trivial. Yep.
If we were to do a problem like this in a different way, but still get the right final answer.
As long as you show your steps, and your steps make sense. Yep. In other words, if I see something where the final answer is correct, but the steps in between make no sense to me, that would still be a pretty close to D score. Okay, but I think I can understand most methods as long as it is logical. I would understand it. But if if someone mentions, I look at a crystal ball and the crystal ball returns this answer, and therefore I'm writing this down, that would be well, if there's a grade lower than F, that's what the answer is that he's going to get. Yep.
If we were able to jump straight to the fifth line, would that be okay as well? We don't have to write out, like,
Yes. So you can, for those of you who are good with math, you can collapse, these steps, and skip to the second to the last line. Yeah. But I can't, track, what is the remaining portion as quick as efficiently as some of you, so I have to write it out. Okay, question number 4. In this question, we are considering a borrowed look-ahead subtractor in which x is the minuend and y is the subtrahend. Quick reminder, in the test, I will not answer any question like, what is the minuend? What is the subtrahend? Okay, I will not answer those questions. I will not answer questions about what is an exclusive OR. I will not answer questions about what is a mod or what is a mod operator. Anything that is described in the notes, I will not answer. Okay, or what is a floor? What is this symbol doing? Or what is a floor function? I will not answer those questions. So that means you guys have to be prepared. Okay, you have to know. I mean, just printing the notes is not going to help you, right? Because you only got so much time during the test. So that means you have to read the notes ahead of you, and you say, oh, this is a notation that I'm not familiar with, highlight it, okay? Put a little post-it next to it. Definition of floor is here. There was a hand, yes?
Will we have to remember that confusing E notation that you only have in the notes and you barely covered?
The D notation,
The
the sigma notation,
yeah.
you have to understand that notation. Yep. So the material does require that notation because it is used to describe, how how the value of a bit representation is derived. Okay, so getting back to this one, in particular, we're examining T3, and I spell it out in this case. Focus on the conjunction, okay? I give this a name U, okay? So I'm defining U to be P2, P1, G0 as a conjunction by itself. If we know that U is 1, okay? And we also know that Y2, not Y1, Y0 is a 1, use the following space to reason out a possible combination of values for x0, x1, x2. Okay, so what is it telling you? These are the constraints that you're given with. P2 and P1 and G0 is 1, because that's basically what U is, okay? And we also know that Y2, not Y1, Y0 is a 1. We want to figure out what is x0, what is x1, and what is x2. That is what we are looking to solve, okay? Well, first of all, where do we start? Definitions, okay? How are the P terms defined? They are how is Pi defined? And this is for a subtraction, right? So make sure that you understand this is a subtractor. So in the subtractor, how is Pi defined?
Not xi plus yi.
Not xi or yi. Very good. Okay, so write it down, right? So anything that is useful in the process of solving this problem, write it down. Pi is, by definition, not xi or yi. It is in the notes. So we also need to know what is gi. So gi is not xi and yi. Okay, those are all from the notes. Okay, okay, so that's useful. But in order to solve this puzzle, it would be helpful if we know the individual bits of y, right? So knowing that y2 and not y1 and y0 is a 1, does that tell you about the values of the value of each individual y?
Yes.
Yes, very good. Because for the conjunction, for the y conjunction to be true, we know that y0 is a 1, okay? And you can just use this notation to say that this is what gives you the idea of this, okay? Okay? Is that good so far? Okay. But on top, we also know that G0 is a 1, P1 is a 1, P2 is a 1, because their conjunction is a 1. Is that okay? So now we can use another pointer here. So we now know that G0, which is x0, y0, is a 1. We know that P1, which is, oops, there's a negation here, negation x1 or y1 is a 1. We know that P2, which is negation of x2 or y2, is also a 1. Is that okay? So this gives us all the constraint that we can possibly derive, because we are expressing everything into x and y's, okay? So now the question is, can we solve what x0 is? The answer is, yeah, we do. Because we know y1 is a 1, okay? So that means this is a 1 here. But because the conjunction of the negation of x0 and y0 is also a 1, that means the negation of x0 is a 1, which also tells us that x0 is 0. Very good. Okay. What about x1? Can we solve the case of x1? Yeah, we can, because we know that y1 is a 0, but we also know that the OR between y1 and the negation of x1 is a 1. Well, y1 is a 0, so not x1 has to be a 1. But if the negation of x1 is a 1, that means x1 is a 0. Okay. So that's 0 as well. What about x2? Do we know conclusively what x2 has to be? Well, let's try to figure that out. y2 is a 1, We plug it in here. Well, that alone can give us an answer of a 1. So x2 can be either one. Okay, there's not enough information to tell us one or the other. So x2 can be 0 or a 1, okay? Because we cannot decide. There's not enough information to restrict it to only one of the two possible values. Okay? So question now is, but we haven't seen anything like this in the lab. Yep. Do you see a theme here? Okay. But have we talked about enough concepts of Boolean expressions to figure this out? I hope so. Okay. So this is basically how I want you to be able to solve the problems. Okay. Which also brings up the next question. How do I study for the test? If the problem solving part of this is probably something that we have not seen. How do I study for the test? You got to understand the concepts, okay? You got to understand what is a conjunction, what is a disjunction. If I tell you a conjunction is a 1, it tells you every single component is a 1 by itself. Okay? So those are the constraints. This is constraint-based problem solving. Okay? You look at all the constraints and go like, okay, what do we know about the constraints? What can this possibly be? And then you try to look at all the constraints already given in the question to say, oh, this one has got to be this because it cannot be anything else. Is that okay? All right. Next question. I'm just looking at the time. We got plenty of time, so we're good. Question 5 of 6. In this question, step-by-step derive the base 10 signed value represented by the following 6-bit binary number. I think that answers the question earlier about the sigma notation, right? So if I were to answer this question and I want to maximize my chance of getting partial credit, I would start with something that I can quote from the notes. Is there anything I can quote from the notes when it comes to the value represented by a signed 6-bit number? Yeah. Okay, what does it look like? V of x here, okay, x being the bit pattern for a signed value, okay, so we say that n is 6, we're dealing with a 6-bit number, okay. So the sigma is going to be from 0 to where? Because it's a signed interpretation, we don't go to the most significant bit, we go to the second most significant bit. So how do we name the most significant bit when it is a 6-bit number? This is bit 0. Remember, count from 0 in most cases. Okay? This is bit 0, 1, 2, 3, 4, 5. The most significant bit is bit 5. So what is the second most significant bit? Bit 4. So this I goes from 0 to 4 only. Okay, so we got xi times 2 to the power of I minus x 5 in this case times 2 to the power of 5. Have we seen this expression? Well, maybe not in this, not with these concrete numbers, but have we seen something like this? Yes. Okay, when we talked about signed number representation, that's when we saw this. And also in signed comparison, I think, that's also mentioned. Okay? So now you just have to expand it out and find out exactly what this number is. So if you expand out the sigma, we got 1 plus 2. There are no 4s, no 8s, but there's 116 minus 0. Because the most significant bit, x5, is a 0. So 0 times 2 to the power of 5 is also 0. Is that okay? So just to be extra sure that we know what the quantity is multiplying to, it's 32. Okay. So you add up all of these values. It is 19, I think, in this case. And that's it. So the first line is kind of important, this line here, because this line shows me that you know at least what knowledge is applicable to this question. Okay? The second line shows me that you know how to correspond between the knowledge and the question that we have on hand. And of course, knowing how to get through all the arithmetic stuff to get to the right answer will bump you from a B to an A. Is that okay? All right. As I'm going through these questions in my mind, I'm already thinking about new ways of asking about the same knowledge, but in different ways. Yes?
I'm having a little bit of trouble reading the very top row, n equals 6. I don't quite know the second item though.
This row here,
6-bit.
Okay, so
6-bit number, pound.
that's what it is?
Yeah.
All right.
Yeah, sorry, my penmanship is not so good when I'm using a tablet. What is below that? You mean this part here? This is a sigma. This is I. Sorry? This is a 4.
Should it be n equals 4?
No. I is going from 0 to 4 because 4 is n minus 2.
That's just the notation. Okay, so you just write that.
Yeah, so if n is the number of bits, then you only want to sum up to the second most significant bit. The most significant bit is n minus 1, or the position is n minus 1, so that makes the second most significant bit located at n minus 2. Now, this is not the only way to get to this answer. Okay, someone can also argue that because the sign bit is a 0, it is not a negative value, and if it's not a negative value, you just add up all the powers of 2 that have a 1 corresponding to that particular binary digit. That also works. Okay. Yep.
Would that get full credit?
That would also get full credit as long as it is fully explained. Yep. As long as it's fully explained, it would be equivalent. Yep. All right. Any other questions about number 5? Nope. Okay. Let's move on to number 6 then. Where's my cursor? There you go. Number 6. In this question, you are given the minuend x as the following 6-bit number, 000011. Step by step, find the subtrahend y such that the binary subtraction x minus y barely sets the overflow flag. And then I define what is barely. Barely means a value that is one off from the one that you choose in the subtraction such that the overflow flag is not set. Okay, is that understood? No? Okay. So let's reformat this question first because we'll probably need to look at the longhand subtraction. So we are looking for something like this. 000011 is our x. We are looking for some y, so the second row is not known. Okay? And we want the overflow flag to be set. Okay? So we want O overflow flag to be a 1 after the entire subtraction. Okay? So that means so barely means a value that is one off from the one that you choose. If you use one that is one off, then it will not set the overflow flag. Not sure whether you. It's a borderline case. It is as close as you can get, but still set the overflow flag. If you change the value that you choose by 1, then it would not set the overflow flag anymore. Is that okay? Yes? Okay, so let me just work out this, and maybe as I work this out, you will understand what I mean by that. Okay? Okay, so first of all, these are the constraints given to you. So now the question is, where do you start? You can't really start here much because we don't really know the rest. Okay, the question does not tell you anything about that. But we might be able to start with the overflow flag, don't you? Don't you think that we can start with the definition of the overflow flag? Okay, so from the notes, what is the definition of the overflow flag? How do we compute the overflow flag? So remember, we only need to look at this particular column here, right? Okay, so we look at the sign bit of the minimum end. We look at the sign bit of the subtrahend. We look at the sign bit of the difference. And there are two parts to this, okay? So we want to kind of figure out what these two parts are. So in a test, you're not going to, I don't want you to reason this out. I want you to just be able to look it up because it is in the notes, okay? So if you look it up, it looks like this, okay? That's one of them, and this is the other one, okay? We reasoned out how we got to this equation in the class already. So when you're answering this question, I don't want you to have to redo the entire reasoning. Just use the result, okay? And you can just say that this is from the notes, okay? All right. So given this, and also given the overflow flag is a 1, does that tell you anything? Oops. Does that tell you anything about the most significant column? It tells you something, right? Not a whole lot, but it does tell you something. Because it cannot be this one, right? It has to be the second conjunction. So if it's the second conjunction, it tells us that the subtrahend sign bit has to be a 1, and the difference sign bit also has to be a 1. So now your job is to say, okay, if that is the case, how do we fill in the other bits so that it barely sets off the overflow flag? Okay, so that becomes the next question. Yep, go ahead.
Work backwards.
You work backwards. Very good. So how do you work backwards? Okay, 0 minus 1, that gives us no choice when it comes to the Q row, right? Because the Q row is just the exclusive OR between the X and Y. So this one has to be a 1. Is that okay? If that one has to be a 1, what do you think this one has to be? It's basically T5 in this case. T5 has to be a 0. Okay, very good. Okay. All right, so we want this to be just barely happening. In other words, now how do I work my way backwards? There's no borrow, because remember the T bit is what links one column to another column. The other bits work on the same column. The T bit is what links to another column. So knowing that this is a 0, what do you think, what constraint have I just placed on this particular bit here? Has to be a 0, because if it was a 1, then it would have set the borrow bit. Okay? Well, 0, 0 minus 0 is here. Okay, so now we have some freedom. In other words, we can now say, okay, we don't know how to configure these two bits. So you look at you evaluate the possibilities. Okay, what are the possibilities? This can be a 1, then this would be a 1. Yes? If this is a 0, that would be a 0. So which one should we choose? Which one will push this to just barely the value that we need to set off the overflow flag? 1, okay. So if this is a 1, then the other bit would also end up as a 1. But why do you choose 1 instead of a 0? What constraint is it going to place to the column to its right? Okay, let's think about this, okay? If I put a 1 here, it will constrain this to be a 1. If I put a 0 here, it will constrain this to be a 0. So which one should we use? Okay, think about this. We want an overflow, right? This is a positive non-negative value. We are subtracting a non-negative value from it, and we somehow end up with a negative value. So which side of the wheel am I overflowing? Remember the number wheel? we are crossing between the most negative value and the most positive value. We are crossing that border. Okay. So which one are we gonna is gonna push us as close as possible to make that happen? Hmm? The largest value for y. So in order to get the largest value of y, it needs to be a 1. Because if we want to put a 1 here, we're going to have a 1 here. Okay? All right?
Wait, doesn't that?
Yeah,
Yeah, that caused a problem.
because we're barely. Wouldn't that make us have a borrow bit on the
Hmm?
in the
A borrow bit?
yeah in the next column actually?
In the next, oh, 0 minus 1. Oh, yeah, you're right.
So it has to be 0.
Has to be a 0. Yep.
But I think the next column is like that.
This one has to be 0 because otherwise we end up with a 1 here. So this would be a 0. Okay. So we also have to get rid of that 1 because we know that has to be a 0. Right? This one has to be 0. 0 minus 0 is 0. And because this one is also a 0, this one has to be a 0 too. Yes? Okay. So because this one is a 0, this one has to be a 0. And that way. And this is 0. Now this time we have a choice. Because when this is T0, T1, this is T2. So T2 being a 0 means we don't end up with a borrow from the column 1, okay? But we have a choice because 1 minus 0 does not have a borrow. 1 minus 1 also does not have a borrow. So we got a choice here. So if I choose a 0 here, that means we are looking at a more negative value. If we put a 1 here, that means we're looking at a less negative value. So which one do I want?
Less negative value, right?
We want a less negative value because we want to just barely set the flags. Okay? So that means I want this to be a 1. If I have a choice, I would choose a 1 because that makes it less negative. 1 minus 1 is a 0. And we have a choice here too. Because we can, we don't have a choice because the borrow to the next is a 0, so this has to be a 0 here. Okay, so once here, we also have a choice here. 1 minus 1 is a 0, 0 minus 0 is a 0. Is that okay? And that's it. This is how we can, one way to derive the answer. Yes?
So given that we choose zeros instead of the ones that we chose, how many points would we have lost?
If you still end up overflowing, you will still get most of the points.
So a B as opposed to an A.
It will be a B instead of an A. Yep. Mm-hmm. Yep.
So if we chose 4 for our subtrahend, why is that not barely overflowing?
If you chose what?
4 for the subtrahend.
4
Yeah,
for
because
the subtrahend?
the minuend is 3. If the subtrahend was 4, wouldn't that overflow?
That is not 4. Okay,
I said if we chose
4.
4 for the subtrahend.
Now 4 in this case would be 0, 0, 0, 1, 0, 0. That would not overflow because you end up with a 0 here and a 0 here. If you have 2 zeros for your minuend and subtrahend, your overflow is guaranteed to be cleared or a 0. Because in order for the overflow flag to be a 1, you have to make one of these two conjunctions to be a 1. If the sign of your minuend and the sign of your subtrahend are the same, then this would be false, right? And also this would be false. Does that make any sense? What you said would end up with a borrow, but not overflow. So it is important to differentiate between the flags that we have talked about. One is a borrow flag, which is the overall borrow from a subtraction. Okay, that's one. One is the sign flag. The sign flag is really the most significant bit of the difference. One is the overflow flag. Okay, the overflow flag is computed exactly this way. And then the other one is the L flag, which is the exclusive OR between the sign flag and the overflow flag. So you have to have those definitions, not memorized, but understood. Okay, there's a big difference between those two. Yes?
Could you explain what you mean by like barely?
Okay, so that's a good question. So if I change this value by 1, okay, in one direction, if I change y by 1 in one direction, the overflow flag will no longer be set. Is that okay? So if I make, okay, so you look at the two ways to bump this value, right? So you can say, what happens when y is 1 less than what it is now? 1, 0, 0, 0, 1, 0. And what if y is 1 more than what it is now, which is 1, 0, 0, 0, 1, 1. Is that okay? Oh, 1, 0, 0. Okay, you're right. I just copied it. And there we go. Okay. Yep, okay, that is correct. So you plug this y in and you say, okay, is overflow flag still set? And the answer is yes, okay? Because to see how that would happen is you just plug it in, you're changing this 1 to a 0, right? It doesn't impact the other bits, which means it will still be overflowing. Is that okay? You plug in the other y, which is 1, 0, 0, 1, 0, 0, in place of the y that we have just derived, and you will find that it is not overflowing anymore. Because it impacts this one, right? It impacts this one, which turns this one into a 1, which turns this one into a 1, which turns this one into a 1, which turns this one into a 0, and we don't have an overflow anymore. So that's what I meant when I said, if you make a change of 1 to the value that you have chosen, in one particular direction, it would not have set the O flag anymore. That is what I said when I said, bare. Yep.
If we were to ask you to explain that concept on the test, would that be okay? If you were confused on what barely was, can we ask
Yes, that would be okay. Yep. If you're not clear about a word in the question itself, I can address that. I can clarify that. And in fact, in this case, I will probably write a note, put it onto the projector, so that the whole class can see how that question is clarified. So there are questions that you can definitely ask during the test. If you need to clarify what the question itself is asking, I can help with those. Okay, it is my responsibility to make it as clear as possible. Sometimes I try my best and it's still not very clear. Okay. On the other hand, if it has to do with knowledge that you're supposed to have understood, or you know where to find, like what is the overflow flag or how the overflow flag is defined, I cannot answer those questions. Is that okay? Does everybody see the line, where I draw that line of what I can answer and what I cannot answer? Okay. Any other questions? We got 5 minutes. Yes.
Just to clarify.
Yes.
So when you say barely, you just mean like get as close as like, so you change one value and that doesn't result in.
If you change the value by 1, then it will no longer meet the criterion.
Okay, so you want to get as close to that, right?
Correct. Because there are many values that will set the overflow flag, but of all of those values, which one is right at the edge? So, yes?
I do want to make sure I know this. The function for a borrow is not x and y, correct?
That is correct.
Okay, make sure.
Assuming that you're asking about the borrow of xy,
Yeah.
then yes, it is defined as not x and y.
Okay.
Yep.
So, by barely, you mean you want us to find the largest possible subgehend, or? So
As long as it meets that requirement, okay? If you you choose a particular value, okay? In this case, this one. If you change that value by 1 in in one direction or the other, and
What bit of the value is what I'm asking here? Because you keep saying change the value, but you can change any bit.
no, change the value represented by this by 1.
Okay.
So you look at the number, well, okay, you can't really easily look at the number wheel, but you can figure out what it's representing, right? Because, okay, so this is relating to an earlier question. What value, if I want to look at a bit pattern as a signed number, what value is this particular thing representing? It's 1 plus 2 minus, okay, let's count, okay? 1, 2, 4, 6, 1, 2, 4, 8, 16, 32. So it's 1 plus 2 minus 32, which is negative 29, okay? So is negative 28 going to not set the overflow flag? Is negative 30 not going to set the overflow flag? The answer is negative 30 is not going to set the overflow flag. Is that okay? Okay, but it's the process that's kind of important, how we work our way backwards. And when we do have a choice, which is starting here, then we have to think it's like, okay, a 0 would do it, but a 1 would do it too, but which way should I go? Yep, go ahead. Oh. Okay, any other questions? No other questions? So my cogs are already turning of how to come up with questions for this test, because I cannot use the same kind of question that I have used in the past. So that means I have to think of a new way to ask these questions. So how do you study? Okay, I got about 3 more minutes. So how do you study for this test? You have to understand the concepts first, okay? So knowledge is important. Not that you have to memorize everything, but you need to know where to find it, okay? So go through the notes, go through your own notes, if you have your own notes, and use Post-its to help you locate specific parts of the notes, okay? So you want to look for definitions, okay? How do we define P? How do we define G, okay? Post-its, okay? Or write it out on a separate piece of paper, which is what I would have done when I was if I were in college, okay? So start with definitions. Then you have to fully understand, the definitions. You have to fully understand what that big wedge and the big V thing mean, okay? You have to understand that one, okay? If you plug in n equals to 2, do we get T3 back, okay? You have to go through that process and understand, what that means, okay? The proofs, I'm not as concerned about the proofs. In other words, every time you see a big, huge, long derivation of a proof, just remember what it starts off with and what it ends up with. Okay, the steps in between is not going to be important as far as the exam is concerned. Okay, but we will cover everything, including the flags. So signed comparison, binary comparison, is going to be the last topic included in exam 1. So is that okay? Are we clear on what is included, what is in the scope of this particular exam? Okay, we're good. We are almost running out of time. So as I said, if you're all done with all the labs, you're caught up completely, there's nothing new today, you're welcome to go to the lab and ask me questions related to all the material for the class, but you do not need to be there. If you're still working on the lab from Tuesday, from last Thursday, I'll be over at the lab, and if you have any questions, I can answer those. So I'll see some of you at the lab, and if not, I'll see the rest of you on Thursday.